Here's a matrix with a bunch of entries in it. It has 4 rows and 3 columns. And by itself, the matrix doesn't mean very much. Since we don't know what these rows and columns correspond to, it's not really all that useful. So now I've taken that matrix and to the columns I've added the numbers 1, 2, and 3. And to the rows, now I have a number of different objects. So the first row matches up with bread in loaves, milk in gallon for the second row. The third row is peanut butter in jars, and the cold cuts are in pounds. With the rows and columns labeled, now this matrix begins to take shape. The columns correspond to 3 different convenience stores, convenience store 1, 2, and 3, and the 4 rows are different grocery items that are carried by those convenience stores. So what this matrix really describes is the number of sales at these convenience stores in the first week of December. So if we look at the first row, second column, the 105, what that means is during the first week in December, 105 loaves of bread were sold in store 2. If we were to pick another one, for instance, we were to go down and pick the fourth row, third column, that means in that first week of December, in convenience store 3, they sold 50 pounds of cold cuts. Every matrix can be classified by its size, and when we talk about size, that refers to the rows and the columns. So in this particular matrix we had 4 rows and 3 columns, so we'd call that a 4 by 3 matrix. If I start looking at some specialized matrices, a square matrix is a matrix that has the same number of rows and columns. So down here in this example, the first row has 101, the second is 623, the third row is -1, 5, and -4. Since we have 3 rows and 3 columns, this is a 3 by 3 square matrix. We can also talk about a row matrix, and all a row matrix is a matrix that's just one row. In this case, we have a 1 by 3 row matrix because this has 1 row and 3 columns. If we have row matrices, we must also have column matrices, and all a column matrix is a matrix with 1 column. So here is a matrix that has 4 rows and 1 column, so we'd call that a 4 by 1 row matrix. When we talk about matrices, we often like to give them names to refer back to them a lot easier, so we usually use capital letters like A, B, C, D. In this case I have capital B being equal to the 3 by 3 matrix, and that will make it a lot easier for me to refer to that, so I don't have to keep writing down those 9 numbers every time I want to refer back to that. 2 matrices are equal if they have the same size and if each pair of corresponding entries are equal. So below I have 2 2 by 3 matrices, 2 rows, 3 columns, and although they have a lot of the same entries, the corresponding entries don't match. So in the first row, first column, the one on the left has a 1, the one on the right has a 0. Because those two things aren't exactly the same, they're not equal matrices. A 0 matrix is another special type of matrix. We usually give it the name capital O, and it's just an m by n matrix in which all the entries are 0. So if I have a 2 by 2 matrix with all the entries being 0, that means this is a 2 by 2 0 matrix. We could have a 2 by 1, a 1 by 2, a 3 by 2. It doesn't make a bit of difference what the size is as long as all the entries are 0.